Right, let's go and get started on chapter number 6. This chapter is very similar to chapter number 5. We spent time talking about modules in chapter number 5. And in fact, in most of the textbooks, these two concepts are merged together. But in this particular textbook, they have two separate chapters discussing modules in chapter number 5 and functions in chapter 6. Basically, they're exactly the same. And if you remember, I mentioned the modules are called functions, methods, subroutines, subprograms, procedures, and many other names. Historically, we have evolved these names. These days in object-oriented programming, they are called methods. But overall, the one of the common words we use is the functions. So we will discuss a lot of these things which we already have discussed in chapter 5. But here in this particular chapter, it talks about some of the predefined functions. So it also talks about user-defined functions, but basically, when we talk about functions, the functions are either given to you in certain libraries, in all the languages, they have their own libraries, or you actually develop your own function. The function you develop on your own is called user-defined function, and the function which is given to you is called predefined function. So let's look at the objectives of this chapter. So this chapter is a kind of brief chapter, so we should not take very long to complete it. This having a technical problem. Let me reopen this chapter again. Okay, so let me open it. It will take me a second or so. Okay, let me close this one. Let me open it. All right, so now hopefully you can see it. So let me share this screen one more time. All right, I think now you can see it. So you can see my screen, and hopefully there'll be no issues. All right, so the in this chapter we'll talk about introduction to functions, generating random numbers, which is not a big deal because it's a random number generator is a function given to us. We can easily call that function and it can generate number in certain ranges. And then it talks about writing your own function. This is what I was referring, user-defined functions. And many of these predefined functions, they come for certain libraries. So it highlights those libraries as well. So what is a function? Is a module. Actually, it is a module, which we talked about in chapter number 5, that returns a value back to the part of the program. Remember, some functions do not return anything. Some functions do return something. So regardless, they're called functions. Even what we discussed in chapter number 5, those are also functions. Those are also methods. But some functions are not designed to return anything. So, but this particular author in this textbook, it kind of differentiating between a function which is a void function, which doesn't return anything, versus function which returns something. But anyway, many languages provide libraries of function that you can use, such as random number generator. A function is a module. It is not like a mod. It is a module, but it returns a value that can be used in your program. I kind of disagree with this differentiation here, but anyway, this is their view. The function doesn't matter. It returns something back to you or doesn't return back to you. Regardless, it's called a function. Regardless, it's called a module. But anyway, the author actually is differentiating here. So library functions are written function, predefined function that come with most of the languages, usually common tasks and save time for the programmer because it allows for the reusability because somebody else has developed that function, tested it, and there's very commonly used functions such as square root, such as power function, absolute value function, or converting function of data type into one other data type. So there are many, many, many different functions. So here in this slide number 4, it talks about the random number generating function. So it is useful for game programs, simulation program, statistical program, computer security such as encryption, and many other places. So in random number generator, and again, this is a pseudocode, it gives you the range between 1 and 100. So it's basically passing two arguments between that range, generate a random number. So 1 and 100 define the range of the number that can be returned and are called arguments. The function is called and a random number is returned assigned to the variable number. So number grabs a value, and this random number generator is not written by us. It is predefined function. It is already, it exists in a library. So we'll see how this particular random number generator is used in Java, Python, and C++ just in a few minutes. So most languages allow coders to write functions. The function header specifies the data type of the value that is returned, the name of the function, and any parameter values, variables. We did that. We did that in chapter number 5. We learned how we can create our own functions by giving the name of the function, and the function has the ability to take either 0 arguments or 1 or 2 or many arguments. And inside the function body, this is where it produces certain results based on the either arguments or based on some kind of internal computation. It basically does something in the body of the function. And then if the function is a value returning function, it returns something back to you. But again, in this textbook, the author is differentiating. The value returning function will return something, and non-value return function, which is a void type, is discussed in chapter number 5. Here in this particular case, let's look at the pseudocode. So here the function is called integer sum. And then you can see it grabs 1, 2 numbers, and it adds the numbers. And notice that all the way at the end, it says return result. So result is just calculated locally in this function and is being returned back to the previous place where it was called. Where exactly we call that functions? We call that function right here. It says sum, first age, second age. So that's where the function is being called. As soon as you hit that statement, the control shifts over here to the function. It goes through the body of the function, does the computation, and returns the result back to us. The result will be captured in this total, and the total will be displayed. So the only difference we see here is that this particular function is designed to return a value. In chapter number 5, when we called functions, they were designed not to return anything back to us. Some concerns: while you can pass many arguments into function, you may only return one value. Yes, most of these are functions. The arguments are passed by value. If you remember in chapter number 5, we talked about Python and Java. They require pass by value arguments. C++, on the other hand, also has something passed by reference where we use ampersand sign at the end of chapter number 5. And in pass by reference, multiple values can be visible in both functions, the calling function and the called function. But here, just for the sake of simplicity, it is basically reminding us you can only return one result, one value at a time. You cannot result multiple values. So functions simply code, increase the speed of development, and ease the facilitation of teamwork. We saw several benefits in chapter number 5. Each function should have flowcharted separately. So of course, we saw that in chapter number 5. When you have a function or some kind of processing of the function, that should be demonstrated separately in flowchart. And IPO can be used to show what a function does. We did that, I think, in chapter number 4, I believe, where we talked about input, what is the processing, what is the output. It's called IPO chart. All right. So here it's going to talk about a couple of additional functions. Functions typically accept one or more values as arguments for perform a mathematical operation using the arguments and return the results. So here, this particular function takes argument as 16, and it's a square root function. As you can see, again, this is a predefined function. We didn't create this one. This was given to us, and it returns something back to us. It takes the argument of 16 and does the square root of that one, which is 4, and stores the result 4 inside this result variable. And this function here is power function. In C++ and some other languages, it might say POW, power, POW. And it basically 4 to the power 2. So it's going to basically return 16, and it's going to store 16 in the area variable. Other common mathematical functions, there are dozens and dozens of them. Here I alluded to some of them. ABS absolute value. When you have positive or negative signs, sometimes you're just dealing with the number itself, not the negatives or positive signs. So you can just grab the absolute value. Cosine and sine and tan and round function to nearest integer for rounding purposes. So data type conversion functions, sometimes you have data into one type and you want to convert into another type. And that's what it basically is telling us, converts value from one data type to another type. So for example, two integer function, again, you will see specific names of these functions in Java and C++, and you'll see how that is the conversion happens. So this particular function is designed to convert a real number into integer and vice versa. The two real converts integer into real number. Now, the question is, why do we need to do this? Because we should not be mixing apples and oranges. We should be very careful. And especially it's called explicit conversion versus implicit conversion. So we need to explicitly make sure that when we are adding, multiplying, or processing the data of same type, we do that kind of conversion. Um, and real numbers can store integers, but like I stated, that when we are processing, in order to avoid any logical errors in the future, it is better to convert them into same type. Otherwise, you might have type mismatch, and many times compiler actually doesn't give you that problem, but sometimes suddenly it starts giving you these strange problems. There are other functions, they allow you to format a number in certain type, certain formation can be created. For example, currency format will be used to format a number to currency. The currency looks like this, dollar sign, comma, and two decimal places. So sometimes if you have a number like that one, and notice that it has a three decimal places, when you apply currency format, it converts into this standard format. There are other functions for, especially for strings, and again, there are dozens and dozens of string functions in each one of these languages. So you actually can check the length of a string. You can append. Append means basically you already have a string. You do not want to overwrite it. You want to add it to it. You want to join. Sometimes you have an upper level, upper convert all the characters of the string into uppercase versus lowercase. You have an ability to do that, especially when you're doing comparison. Remember, if you remember, I think in chapter 2, we studied that uppercase and lowercase, these are two different things, especially when we talk about ASCII values. So it is better to, when before you do the comparison, you convert them into all in a similar case, either all uppercase or lowercase. It allows you to avoid any problems. And substring can extract a character or a portion of a string out of a string. So let's say you have 10 characters in a string. So you can go to the third character and then you can extract 3 characters. So substring allows you to go to a specific location in a string and extract something to it from it. So again, what's the purpose? You'll see that value later on when you want to go to a specific location in a large document and extract something specific from the document. Contains identifies similar things, string with 2 strings. Just you want to kind of looking for something in a string, you can use the contain function. String to integer and string to real. Sometimes that particular language allows you to grab everything in a string format, especially Python does that frequently. Then you want to convert into a specific format such as a whole number or a real number. Then you have the ability to convert into those format. Is integer and is real, test numbers to see if they can be converted into a string as well. All right, so we are done with the chapter. Let's see some of the implementation of these concepts we have talked about. In order to generate random numbers in Java, so first, as usual, we will go over Java. And we will include this random number generator library. So this random is added, is imported. So then you can use this random number. This is the function you're creating and calling, and then it basically creates a random number during the runtime. This new keyword allows you to create something runtime. Whatever number is generated, it will be stored in this variable here, random numbers. To random number integer, use the next integer. So this is the one if I want to create something randomly. So if I put an argument with that one, next integer 10, for example, then it's going to create anything between 0 and 9. And the last particular number will not be included in the random number generator. And of course, when you run that particular random number start next int, it's going to store something in the number, and that random number can be used for gaming, simulation, statistical, and other purposes. How do I use it? All right. So first, make sure you have this library. Library is included. And then you are in the main function. So you will run this line of code. This line of code basically calls that random function. And then once you call that one, then you want to create an integer, random number integer. And notice that in this particular case, we are using 100. So 100 is basically is the range. If you saw the previous one, we saw the range of 10. So this will be the range, any number between 0 and 100, 0 and 100, it will be generated. And you can see we ran this about 6 times. Uh, yeah, 5 times, because we start with 1, not 0. So 5 times, and then 5 numbers are generated. Okay. So writing your own value returning methods in Java. So we did something very similar. In fact, in chapter number 5, we did extensively. The only difference is that is this time it is just returning something back to us. So here we are creating a function called sum. Sum takes 2 arguments. We saw this in chapter number 5. Those 2 arguments will be captured here. And then basically here you're adding these 2 numbers, storing the results in result, and returning. Notice that that's a lowercase return. This is a keyword in Java, C++, and many other languages. So it's basically going to return something back to you. How do you call that particular function? So here's your main function. In main function, you have 2 variables, or 3 variables actually. And then you will take these numbers from the user. So user provides you these numbers. You're picking up from the user. You say enter your age, enter your best friend's age. Then you pass on those 2 ages to some function. You pass on your age and your friend's age to the sum function. Sum function captures those 2 ages in number 1 and number 2. It adds them together, produces a result, returns the result. When the result is returned, it is stored in the total variable. And then you can display the total right there. And you can argue, well, why do I have to create a separate function? Why can't I just write there in the main function? Yes, you could. This is just an example. Some of the functionalities could be very cumbersome. And also many of these steps might not be 1 or 2 steps, might be hundreds of steps. So that's why it's better to have functions, because we are just learning how to create our own functions. In chapter number 5, we learned how to create functions which do not return anything. Here we are learning how the functions are basically designed to return something back to us. All right, we'll do the same thing in Python. So in Python, you will be including a library called random. And here, random integer is going to create something between 1 and 100. It says a random number in range will be assigned to the number variable. All right, how do we run it? So here you make sure you include that one. Here's your main function. In the main function, you're running a for loop. And then you basically call that random integer with a range, and it produces that number every time and displays the number, and it's going to give you those 5 numbers here because we are running this 5 times. Okay, very similar. So here we are creating our own function called sum, and define sum, and then sum takes 2 arguments, adds them together, returns the result. So how do I call this one? So this is the same function I just showed you earlier. And then you call that function right there. You pass on the first age and second age, and those 2 results, the result will be sent back to you and will be stored in total. And very similar to Java, it will be displayed here. Finally, and this stuff is really easy, guys, because we did this in chapter number 5. So I'm not rushing through it because we already have experience from chapter number 5, and we learned how to produce these kind of functions. So C++ will include this particular library, C standard library, cstdlib. And once this library is included, because this random number generator comes from that library, it is already in a pre-existing function. So, and you can store in a number here. So how do I use it? You can also use a seed. Seed for seed, you can use a time. So what exactly that means? To get a random number sequence of numbers, each time you run the program, you must seed the random number generator with a different value. A common technique is used to the time function to see the random number generator. So the time function returns the number of seconds that have elapsed since midnight, January 1, 1970. The time function requires the following include directive. So you include this library first, and oops, and then you basically call that time function. That will be your seed. And then you pass that seed to srand, which is a function for random number generator. And then you display that one right there. And then it's if how do you call it? You can actually put it right there in a for loop. We did in Java and Python, so it's going to run 5 times. And then you're taking it might give you a very large number. So you are taking a remainder. This is a remainder symbol here, and remainder of dividing by basically 100, and whatever the remainder is, it will be added to 1. And then if you want to not to go through all this stuff and just want to test it out, you can test it out. It's going to show you the numbers in the original format, and then you'll see the logic behind why we are going through that algorithm. And then here we are just basically creating our sum function, taking 2 arguments like we saw earlier, and basically returning the results. Very much identical to Java we saw earlier in Java. So this is your function. You call that function here, pass first age and second age. They're captured in number 1 and number 2, and the result will be sent back, which will be stored in total, and it will be displayed right there. All right, guys. This chapter was really easy because we already had pretty good idea how the modules are created and how they behave. So this was kind of the repetition of our previous discussion. For this particular author in this book, they divided it into chapters. Normally it's just one chapter, but I think maybe to decrease the size of the chapter, they may divide it into 2 chapters. All right, so I'll catch you later for chapter number 7.